So this is what you need to know for matrices. A matrix is a rectangular array. In brackets, those brackets could be square or round. Different types of matrices we've experienced could be square, they can be column, they could be row matrices, or they could be diagonal matrices where non-zero elements appear on the diagonals. If you think about a timeline from the start of maths until today, matrices were only developed in 1851. That makes matrices a relatively new field of mathematics on the whole scale of mathematical development. Two men, Sylvester and Cayley, designed matrices as a way to define linear transformations, and that was their original use. Now with matrices, we don't talk about size being big or small. We talk about matrices as having an order. So an order is just a representation of how many rows and columns they have. Each matrix is made up of elements, and those elements can be referred to by which row and which column they appear in. For this week's learning briefs, you've had to look at three basic operations: addition, subtraction, and scalar multiplication. Addition of matrices happens by adding similarly placed elements. That it means that the matrices have to be the same order, that is the same size, so that you can match element for element and add them together. Similarly, with subtraction, we subtract similarly placed elements. So like addition, we can only subtract matrices that are the same order, that is the same size, so that we can subtract and match element for element. Scalar multiplication is a little bit different. Now scalar just is a number. It can be 2, a half, 0, it can be a fraction, a decimal, a square root, or even pi. By scalar multiplication, what we want to do is we want to multiply each individual element by the scalar amount, and that changes that value. So that means for this example, we could multiply the matrix 1, 2, 3, 4 by 2 and get 2, 4, 6, 8. Or we could abstract it to using k's and get Ka, Kb, Kc, and Kd. Matrix multiplication means that the columns of the first have to match the rows of the second, and then the result will be a matrix of M by P order. That is the order, not the actual answer. The definition for matrix multiplication gets a bit confusing, but if we use those two matrices, we get something that looks like that. I suggest you watch a heap of YouTube videos to see what matrix multiplication looks like. That's what you need to know for matrices for week 3.